All right, so for this video, we're going to keep looking at our rational functions and graphing them, and we're going to still do everything we did in the last video where we find those 5 key features, but now we're actually going to take those features and put them on a graph and use a calculator to see what the graph looks like so we can kind of fill in the rest. If you do not have a calculator, Desmos.com will give you everything that you need to be able to get the shape of these graphs, right? Most of it's going to come from these 5 key features, but then we'll use the calculator to kind of fill in the blanks that what we don't look at. All right, so just a quick review, right? To find our x-intercept, remember we have shortcuts for all of these, and the first thing you do for all of these rational functions is you factor and simplify, if possible. All right, that is some ugly handwriting, but that is the first thing that we always do. Okay, and it's a little bit out of order, but if something factors and cancels and you can simplify your fraction, that's when you have a whole. All right, anything that cancels is where you're going to have a whole, right? And we do it first, but then we come back to the wholes right when we get ready to graph, all right? So always factor and cancel if you can. All right, so then our x-intercept, the shortcut comes from setting your numerator equal to 0. All right, it's the same thing as plugging in 0 for y. All right, and then your ordered pair is always an x comma 0 for your x-intercept, whatever your intercept is, comma 0. You can have no x-intercept, you can have 1, you can have 5. All right, it just depends on the graph, but you can have multiple x-intercepts. You can only have one y-intercept, and you could have none, but you can't have more than one. And to find the y-intercept, you divide your constants, because you end up plugging in 0 for x, and every term that has an x in it goes away, and you're left with the constants that are on the end. Okay, your vertical asymptotes come from anything that makes your function undefined, which is when you divide by 0, which you cannot do. So to find your vertical asymptotes, you set your denominator equal to 0. And again, you could have multiple vertical asymptotes, or you might have none. It just depends on the equation. Your horizontal asymptotes, we turn to our buddy Bodo. I can't talk. We turn to our buddy Bobo. All right, so we got Bobo, Botten, Spud. And it's got to be either Bobo, Botten, or Spud every time. Bobo is bigger on bottom, so if you have a bigger exponent on the bottom, your asymptote's at y equals 0. Right? Botten, if it's bigger on top, there's none, no horizontal asymptote. And then Spud, same power, you divide, and that means you divide your coefficients. Remember, you're always talking about the biggest exponents, so you're looking at the numbers that are in front of the terms with the biggest exponents, your coefficients. All right, so we got 3 examples we're going to power through. The first one, right, we got 2 over x squared minus 4x minus 5. The first thing we're going to do is factor. Okay, the top, we can't do anything. 2 is as simple as it gets. On the bottom, it's a plain Jane trinomial, so we can multiply to c and add to b. Right, so my only factors of 5 are 1 and 5. I need one of each sign because it's a negative 5, and the bigger number keeps the sign in the middle. So then that means that the minus stays with the 5, and the 1 gets a plus. Nothing cancels, so just a little tidbit means that there's going to be no holes. So there's one of our key features taken care of right off the bat. No holes because nothing canceled. Okay, then we're just going to start going through the list. So we'll start with our x-intercept. So our x-intercept comes from setting the numerator equal to 0. Well, my numerator is 2. So when I set 2 equal to 0, that's not possible. That is a false statement. 2 cannot equal 0. So then that means that there is no x-intercept. All right, it's not possible for the numerator to equal 0, so there isn't one. All right, your y-intercept comes from dividing the constants. So I'd go back to your original. All right, and my original has a 2 up top and a negative 5 on the bottom. Because remember, you plug in 0 for all the x's, so anything that has an x goes away. So up top, I'm left with a 2. On the bottom, I have a negative 5. I can't simplify that fraction. 2 over 5, that's as simple as it gets. So I'm just going to write my ordered pair, 0 and negative 2/5. All right, vertical asymptote comes from setting your denominator equal to 0. And just to save a step, Anytime I'm setting equal to 0, I'm going to use the factored form if I have that option, right? Because now that it's factored, to solve this, I just have to set my factors equal to 0. Then I solve for x. So for the first one, we can add 5. So x equals 5. And then for the second one, subtract 1. So x equals -1. So I have two vertical asymptotes, one at x equals 5 and one at x equals -1. And then we have our horizontal asymptote. We turn to Bobo. So Bobo, Botten, Spud. So if I look at my exponents on the top, I don't see an exponent at all because there isn't an x. Right? So if there's no x, that's kind of like we could say this is really x to the 0 power because I have no x's up there, right? And x to the 0 is really just 1, so it goes away. On the bottom, I have x squared, so I have a 2. So my exponent on the bottom is bigger than the exponent on the top, which means that this one's Bobo, bigger on bottom. And if it's bigger on the bottom, that means that my asymptote is at 0. Remember, your horizontal asymptote is always at y equals 0. All right? Once you find your key features, we just put them on our graph. So I don't have an x-intercept to put on there, nothing to graph there, but I do have a y-intercept at -2/5. That's close to a half, right? So I'm going to go 0 and then about where -2/5 is. Just an estimate, not a huge deal to be exact. We're just sketching our graphs. Right? I have two vertical asymptotes. Remember, asymptotes, we draw on the graph with a dotted line. So my vertical means it goes up and down. I have two. One of them is at x equals 5. So I'm going to go to 5 on the x-axis, and that's where I'm going to draw a vertical line. And then I'm going to go to -1 and draw a vertical line. All right, and then my horizontal asymptote means it goes left and right, right? I have one at 0. So I'm going to go to 0 on the y-axis now because I'm going left and right. And it's going to actually be right on the x-axis. I'm going to draw my dotted line. All right, once you do this much, it's just a matter of looking at the graph on the calculator or on Desmos, depending on what you got to work with, right? And seeing what the actual graph looks like. All right, so I'm going to attempt to change my screen to my calculator. Okay, now I've already typed in some stuff here. We'll get to those later, but I'm going to type in the first one and just kind of review using the calculator. You can do this with using your divide sign, but you've got to make sure to use parentheses if you do that. So another cheat that we can use is to go ahead and put it in fraction form so it's nice and pretty and it looks just like it does on your paper. So to do that, we press alpha y equals, and that's going to bring up a menu. And this first one, n/d, right, that's numerator, denominator, that is our fraction. And it opens it up for you so you can type it in just like it's written. So this one was 2 in the numerator. And I'm just going to scroll down to the denominator, and we got x squared minus 4x minus 5. And you can put the factored form in there too. That's fine. Either way works because it's the same thing. So I'm going to go to my graph and let it load. All right, it looks kind of weird because your calculator struggles with asymptotes, right? Because the calculator knows that it can't touch that asymptote, right? It's going to get infinitely close to it, but then your calculator can't get its line skinny enough to be able to draw it all the time, right? But you can see here, this one shoots up forever, then shoots down forever, and kind of right in the middle, there's my asymptote at -1. Okay, over here, where it kind of breaks, that's at +5 because that's where I have another asymptote. And your calculator, if I were to zoom in, you would see it going up more, but at this window, right, it can't get that close, so it just stops, right? It gets as close as it can. But you can see my two vertical asymptotes, right? Remember, your horizontal asymptote talks about end behavior. So if I look at the ends of my graph, right, it looks like it's getting super, super close to 0. And then on this side, super, super close to 0. All right. So let me get back to, well, let me try to get back to my notebook here. And I'm just going to sketch that. So I know that it was up here, really close to the asymptote, then came down, got close to this one. Right, and it did the same thing on the far right side, right? And again, we're just sketching, right? And then down here, I have like that upside down U, right? But I have a point, So let's make sure we go through our point. It defeats the purpose if you put any points on here and then don't use them. So I know I got to get close to this asymptote, and then it's going to come up and it's going to go through that point, and then it kind of flattened out, and then it went back down and got close. Oh dear, that's a hot mess. But you get the idea. All right. So once you put all of our key features on there, we're just going to use some type of graphing device to get the shape, right, and get the idea of what it looks like. And that's pretty much it. That's all we're going to do. All right, so 2 more examples. Our next one, right, the first thing we're going to do is factors. I got x squared minus 16 over x plus 3. Well, x squared minus 16, I can factor using difference of squares. So that's going to become x plus 4, x minus 4. And I can't do anything with x plus 3. That's as simple as it gets. Right? Nothing cancels. So again, you can kind of make note, there's no holes. We don't have to even worry about that one. We've only got 4 things to find now because there is no hole, and that was our 5th key feature. So we're going to start with our x-intercept, and we set our numerator equal to 0. So I'm going to use the factored form, because that's going to let me skip to setting my factors equal to 0. Right, and then I can subtract 4, so x equals negative 4. And then for this one, add 4, so x equals positive 4. Right, so now I have 2 x-intercepts. One of them is at negative 4, 0, and one of them is at positive 4, 0. I'm going to go ahead and put those on the graph. So I'm going to come to negative 4, 0, positive 4, 0. Then move on to the y-intercept. Right, y-intercept is where I'm going to divide my constants. So the constant that's up top is that negative 16, and on the bottom, positive 3. Uh-oh. And I can't simplify the 16 over 3, so I'm just going to write my answer as negative 16 thirds. Goodness gracious. That's 0, negative 16 thirds. I keep pressing something. All right, and I'm going to go ahead and graph that. And I'm going to estimate. Okay, 3 goes into 16 5 times. That could get you to 15. So it's 5 1/3, right? Negative 5 1/3. So I'm going to come down to negative 5 and approximate where a third is. So we'll stay right there. All right, vertical asymptote. Set the denominator equal to 0. All right, subtract 3. So then x equals negative 3. So that's where I'm going to have a vertical dotted line. So I'm going to go to negative 3 on the x-axis and put a vertical line. I'll try to. It's a little struggle bus today. All right, and then the horizontal, we turn to Bobo, our buddy Bobo. So if I go back to my original here, I have x to the 2nd power up top and x to the 1st power on the bottom. So I got a 2 up top and a 1 on the bottom, which means it's bigger on top. So bigger on top is bottom, and bottom means none, right? There is no horizontal asymptote, so I don't have any horizontal dotted line to draw. So that's all I can graph. That's all that I get from my key features. All right, and let me get back to my calculator. And I'm going to go to y equals, and I cheated just so I didn't have to type these in and make the video take longer. So let me turn that one off and turn the second one on and go to the graph and let it load. All right, so looking at the graph, you can see where I have this kind of line down the middle of these 2 curves here where my vertical asymptote is at negative 3, because that's where they're going to be approaching as they go up and down. And I don't have a horizontal asymptote, so there's not going to be like an imaginary horizontal line going through there, but you can kind of see how there's like a diagonal one, right? Where it looks like, you know, as it goes to the left, it gets closer to this diagonal line, and as it goes to the right and up, it gets close to that diagonal line. And that's actually another kind of asymptote that we call a slant or an oblique asymptote, right? Anytime your rational function doesn't have a horizontal asymptote, if it's bottom, that means that there is a slant or oblique asymptote. So you're going to have this kind of shape going on with your graph where it approaches a slanted line. Now, we're not going to worry about finding them or anything, but just know that if there's no horizontal, if it's bottom, you've got this slant or oblique asymptote. All right, so let me hop back over to the notebook. and I'm going to attempt to sketch it. All right, so I know that it's got to go through this point here, and up here, it, you know, got close to my asymptote, and then it kind of approached that dotted line, sort of, kind of. I was struggling. All right, and then over here, it's got to get close to my asymptote, right, down here, but then it comes up, and it's got to go through these, try to go through these points, and also go towards that slanted line, right? You have that oblique asymptote that was running through there. Now, this is a hot mess of a sketch, but you get the idea. It's kind of hard to draw on these little tablet things without being able to see it. But there's our example 2 with no horizontal asymptote, and you can see the idea of the slant asymptote or the oblique asymptote. And our last example, all right, we've got x squared minus 5x minus 14, all right, and I can factor that, plain Jane. I want to multiply negative 14 but add to negative 5, and that's going to be a negative 7 and a positive 2. And then for the 2x squared plus 3x minus 2 on the bottom, it's not plain Jane, so we're going to have to do bottoms up. So the first thing we're going to do is move that 2, right, that a, and make it part of c by multiplying. So we get x squared plus 3x minus 4. Now it's plain Jane. Now we can factor. I want to multiply negative 4 but add to 3. That's going to be a positive 4 and a negative 1. But then I got to take that a back out. So I'm going to divide both of these by that original a. Well, 4 over 2 I can simplify to x plus 2. And 1 over 2 I can't simplify, so I'm going to do bottoms up, and that's going to become 2x minus 1. So now on the bottom, I have x plus 2 and 2x minus 1. And you should be, you know, alarm going off in your head. You should see something right now. I have x plus 2 on top and on bottom. So that means they cancel. And I can simplify my fraction. And my new fraction becomes x minus 7 over 2x minus 1. And what that also tells me is anytime anything cancels, that means now for this problem, we have a hole. All right, so we have a hole at whatever makes what canceled equal to 0. So I have to take x plus 2 and set it equal to 0, and then to solve, I get x equals negative 2. So that means I have a hole at x equals negative 2. And then we're going to come back to that in a little bit. We're going to come back and do that at the end. So let's go back in order, find our other key features. So to start with, I have an x-intercept. All right, x-intercept means we set the numerator equal to 0. Now remember, I simplified my fraction, which means now this is the fraction that I use to find all my key features. I don't go back to the original because I simplified it. I got rid of the x plus 2. So now I'm looking at x minus 7 over 2x minus 1. So I'm going to set x minus 7 equal to 0. Add 7 to both sides, and I get x equals 7. So that means I have an x-intercept, come over here, at 7, 0. All right. Find my y-intercept. Oh, let me go ahead and put my 7, 0 on there. Oh, my graph's too small. That's annoying. We'll estimate. We'll say 7's right there. 7, 0. That's gross. All right, but my y-intercept comes from dividing the constant. So go back to my simplified equation here. The constant up top is a negative 7, and on the bottom is a negative 1. All right, because all my x's and stuff go away. And all I can do to simplify that is cancel out the negatives, and then 7 over 1 is just 7. So I have a y-intercept at 0, 7. And again, it's annoying. It's not on my graph because I did not put the right size graph on this problem. My apologies. Vertical asymptote. Set your denominator equal to 0. All right. And this is just a two-step problem instead of a one-step problem. Nothing wrong with it. Same idea. Set it equal to 0 and solve. So I'm going to add 1 to both sides. So 2x equals 1, and then divide by 2. So I have a vertical asymptote at x equals 1/2. Right? So I'm going to go to 1/2, which is halfway in this first box. And that's where I'm going to put my dotted line. Try to put my dotted line. Although it's not going to be super straight. Okay, and then the last thing we have to find is our horizontal asymptote. So we go to Bobo. So if I come to my simplified fraction, I have x to the first power and then 2x to the first power. So they're both to the first power, so they're the same power, which means that this one is spud. So if it's the same power, you divide the numbers in front of those powers. So in front of the x to the first is a 1. In front of the bottom, x to the first is a 2. So I have y equals 1 over 2, and I can't simplify it. So my asymptote is at 1/2. So my horizontal asymptote, same idea as the vertical. I'm going to go to a struggle about where a half is and try to draw a dotted line. All right, and we are almost done and ready to go look at the graph, but we have to go back to that hole. All right, I need a little more information when it comes to actually putting it on the graph. I need to know more about where that hole is. Right now, I know it's at x equals -2. That means it could be anywhere on this vertical line here because that's everywhere that x equals -2. I need to know exactly where to put that hole, right? So, and my hole is literally going to be a point that's open. I got to put that somewhere on my graph. So I need to find the ordered pair for where that hole is, right? So I know the x value is at -2. So I need to figure out my y value. So to do that, I plug in x. So I'm going to come to my equation over here and plug in -2. So I have -2 minus 7 up top, and then 2 times -2 minus 1 on the bottom. Well, -2 minus 7 is -9. And then 2 times -2 is -4, minus 1 is -5. All right, 9 over 5 doesn't simplify, but a negative over a negative becomes a positive. So that means I have a hole specifically at the point -2, 9/5. All right, well, 9 over 5, okay, 5 goes into 9 one time with a remainder of 4, so that's 1 4/5. So that means I'm going to go to -2, and then 1 4/5, which we're going to estimate to be right there. Oh, goodness gracious, I'm putting a point. And I need to put a hole, because there's a hole there. My graph doesn't actually go there. It looks like it goes right through that point, but it jumps over that one specific point. All right, then we're going to go to the calculator. Okay, and we go to y equals, and turn the second one off and the third one on. There's my simplified fraction. Go to my graph. All right, so you can see it looks like it's a 1/2 right there where it's going to get close to. And same thing here. You can imagine a vertical line there at 1/2, right? No oblique asymptote this time because I have a horizontal asymptote. Okay, so now let me go back to the tablet. Okay, and that tells me that my graph gets close to this asymptote, comes up to the hole but jumps over it, then goes all the way through that point into the asymptote. And then this one's going to start close to this asymptote and come up through my x-intercept and get close to the other asymptote. And there's a rather rough sketch of this graph. All right, so that's the gist. We're taking what we did in the last video and just putting it on paper. All right, we're doing more than just finding it. We're actually graphing it. Okay, now your assignment to go along with this is on Delta Math. So I do want to take a second to show you how it works on Delta Math, because we're not just typing in an answer anymore, we're actually graphing. All right, so let me pull up, maybe. Let me see if I can find it. Quit pulling up. Get out. Struggling. Okay, I don't know if you can see this. I don't feel like you can see this. Let me get back to my Zoom. New share. Let's try that again. Now, hopefully you can see this. All right, so here's Delta Math. So here's what it's going to look like when you have a problem, right? It's going to give you an equation, a fraction, just like what we just did, right? But then it's going to give you this empty graph and our 5 key features here. So what you do is, if I have a vertical asymptote, I click the vertical asymptote button, and it's going to put this generic dotted line over here. It's like if my vertical asymptote was at I don't know, 1/2 like we just did, I can move this to 1/2. All right, same thing with the horizontal asymptote. So like for that last one, we had a horizontal asymptote at y = 1/2. So you just drag it where you want it. Okay, my x-intercept for that one was at 7. So as soon as you press the x-intercept, it puts a dot on your x-axis. You can click and drag it. So I'm going to put it at 7. Same thing with the y-intercept. It was at 7. All right, and then I had a hole at that -2 and 1 and some change, right? Something like that. So you're just moving the points where you want them, right? If I didn't have a hole, I don't have to press the hole button, right? Or if I didn't have a horizontal asymptote, right? And then you're going to press the plot rational function and let it draw a rational function for you. All right, now, if I had moved these points, let's make it kind of gross looking. All right, then press plot rational function, and I can't get anything that goes through those points, right? That should tell you you're wrong and you need to try adjusting them again. But it's just like you guys did before. You're going to do this, you scroll down, press submit answer, and it's going to tell you if you're right or wrong. You get a second chance. If you get it wrong again, it's going to show you the work for how to do that problem, and you get a new problem, right? So that's the cool thing about Delta Math, is that it shows you how you can do it and you can fix it and do it again in the future, right? But I did just want to show you because the graphing is a little weird, because you have to actually click the individual pieces to get them to show up on your graph, and then click and drag them as you need to. All right. So other than that, that's all we got for graphing rational functions.